This video is brought to you by IXL, used by millions of students worldwide to get ahead in math, English, and more.
In this lesson, we are going to learn how to factor quadratics using algebra tiles. Did you ever use arrays when you were learning to multiply? Arrays are a way of showing multiplication using the area of a rectangle. For a rectangle, you multiply length times width to find the area. So in an array, you multiply the number of columns by the number of rows to find the product. Let's say you wanted to find the factor pairs of 12 using an array. We could make a rectangle or an array with one row of 12. That's 1 times 12. Since multiplication is commutative, we could also say this as 12 times 1. We could also have made an array of 2 rows of 6. That's 2 times 6, or 6 times 2. Is there another way? Yes. 3 rows of 4. 3 times 4, or 4 times 3. We can do the same thing to factor quadratics using algebra tiles. To model a quadratic, we need 3 types of algebra tiles. The unit tile, which has a value of 1, the variable tile, which has a value of x, and the variable squared tile, which has a value of x squared. Let's use algebra tiles to factor the quadratic 4x squared plus 6x plus 2. To model this expression in tiles, we need 4 x squared tiles, 6 x tiles, and 2 unit tiles. If we arrange these tiles in a rectangle like this, then we can determine the factors of this expression by looking at the length and the width of the rectangle, just like we did with the array. Instead of an array, we call this an area model. To find the length and width, let's look at each column one at a time and each row one at a time. Let's start by finding the length. How long is this first column? In the first column, we have 2 x squared tiles and 1 x tile. What is the length of all of these tiles? X. The second column is identical to the first, so its length is also x. What about the third column? It has 2 x tiles and 1 unit tile. These tiles all have a length of 1. The fourth column is the same, so it's also 1. The total length of the area model is x plus 1 plus 1, or 2x plus 2. What about the width? Let's look at each row. The first row has 2 x squared tiles and 2 x tiles. What is the width of this row? X. The second row is exactly the same. It also has a width of x. What about the third row? What is the width of these 2 variable tiles and 2 unit tiles in the last row? It's 1. So the width of the entire rectangle is 2x plus 1. That means 4x squared plus 6x plus 2 factors to 2x plus 2 times 2x plus 1. Let's try another. This time we'll use the area model given to us to factor x squared plus 6x plus 8. First, let's make sure we have the correct tiles to represent the polynomial. The terms of our polynomial are x squared, or 1x squared, 6x, and 8. So we need 1 x squared tile, 6 x tiles, and 8 unit tiles. That's right. Our rectangle has the area x squared plus 6x plus 8. If we find the length and width of this rectangle, we'll know our factors. What's the length? Let's look at one column at a time. So what is the length of this first column? It's x. What about the second column? 1. The third, fourth, and fifth columns all match the second, so they also have a length of 1. The entire length is 1x and 4 units, or x plus 4. Now we look at the width, row by row. What is the width of the first row? That's x. What about the second row? That width is 1. The third row matches the second, so it also has a width of 1. The entire width is 1x and 2 units, or x plus 2. The factors of this quadratic are x plus 4 and x plus 2. Let's look at one last example. This area model represents 3x squared plus 10x plus 3. Let's find the factors. Do our tiles accurately represent our polynomial? We need 3 x squared tiles. That's good. We need 10 x tiles. Yep. 1 x tile on the side and 9 on the bottom is 10 total x tiles. And we need 3 unit tiles. We have that as well. So our rectangle models 3x squared plus 10x plus 3. Now let's find the factors by looking at the length and the width of the rectangle. Let's start with the length. What is the length of this first column? It's x. The second and the third columns match the first, so their lengths are also x. What about the fourth column? That's 1. So the length is 3x plus 1. Now let's look at the width. What is the width of the first row? That's x. What about the second row? That width is 1. The third and the fourth rows match the second, so they also have a width of 1. The entire width is 1x and 3 units, or x plus 3. This area model represents the expression 3x plus 1 times x plus 3. Algebra tiles are a fun and helpful way to visualize factors of quadratics. Now try some on your own.
Head over to IXL.com for more practice on this skill and thousands more videos in math and language arts.